Hey folks, how you doing? All right. Yes, my name's Cody with Platform 9. I'm a cloud architect there. One of the projects that I'm really excited about is Fission. It's our serverless framework, completely open source, free for everyone to use, and it's based off of Kubernetes. So I'm going to start out by telling you a little bit about what Platform 9 does, kind of where we are in the space. We've been doing OpenStack for a while, and then Kubernetes, and now we're doing serverless. So I'll kind of walk you through that a little bit. And then we'll dive into some pretty cool demos and talk about what we've built here. So I'm not going to spend too much time with this, but essentially for the last, I don't know, since virtualization has started, and there were Windows teams and Linux teams back in the day, you guys have been siloing. Every new technology you bring in, you create a new IT silo. And I'm sure you've heard this pitch before, that these silos are bad and that you shouldn't have them. And so what we're doing is we're really trying to combine all the virtualization frameworks, all the containerization frameworks, and all of the public clouds into a single unified environment based off of open source technologies, so OpenStack, Kubernetes, and Fission, utilize the OpenStack API to drive inside of the public clouds, right? So we were on stage at the Barcelona summit talking about OpenStack Omni. That's something that we built, which is the public cloud drivers for OpenStack. And this demo today will be showing you part of that. So why Platform 9? Because we're awesome. A little bit about our technology. We're a SaaS company, right? So Platform 9 basically allows you to run a private cloud inside your data center with us hosting the control plane and RabbitMQ and the message and MySQL and all the APIs and all of the stuff that's hard and difficult to install, monitor, maintain, and upgrade in OpenStack. We make that really easy by allowing you guys to consume it. Just download a small host agent. That host agent connects to our control plane via outbound HTTPS, connects to all these services, and you have OpenStack up and running in 2 hours, right? It's awesome. Trust me. So we've been heavy in the OpenStack community. We've been contributing back, right? So two of the projects that we've contributed back to the community are OpenStack Omni, which are those public cloud drivers that at the Barcelona event we delivered Amazon integration. Then at the Boston event, we enabled the GCP integration. And then at the Sydney summit, we enabled the Azure integration. So now all three major public clouds have true OpenStack drivers for Nova, Neutron, Glance, Cinder, all of that. So we'll be showing you in the Amazon integration today. And then VMHA, right? So a big reason people aren't jumping away from VMware is because they have legacy workloads. So we kind of built a legacy VMHA solution on top of OpenStack. That's based on the Masakari framework, okay? We're also doing Kubernetes, right? So we've been in Kubernetes for quite a while, this is what led us into our serverless framework, Fission. But we've been leveraging Kubernetes. We got in pretty early we started developing it in 2015, had our first pre-release in early 2016. And out of a hackathon shortly after that, one of our brilliant engineers figured out that Kubernetes is the perfect place to run serverless functions, and the framework itself makes it super easy to run serverless. So in a 2-day hackathon, he built a prototype of Fission, which is now Fission today. As soon as we saw that, we knew we had something special. So we actually built an entire team around him to really make this thing work well. Some of the other stuff that we're doing is really building out the ability for you to use spot instances inside of your Kubernetes clusters, because Kubernetes is designed to allow instances to fall off and come back and all of that. So that's something else we've contributed as well. All right, demo time. Cool, I got through those slides in under 5 minutes. So the first thing we're going to do is I'm going to show you the OpenStack Omni and Managed Kubernetes, which is the base of this presentation, right? So let's, okay, come on, Google Slides. All right. So we have a an OpenStack environment today. This is our web UI. We have Horizon as well, but in order to show you Kubernetes and OpenStack integrated together, we have to use our UI. So I'm going to flip over to Kubernetes. Let me make this slightly larger. That works. So in the Kubernetes environment, right, we have a cluster that's deployed here. OpenStack Vancouver rocks. I have 9 hosts, a nice Kubernetes and cluster here, and we have a built-in CLI here, so I can do like a kubectl git nodes, right? So we kind of make it really easy to jump into Kubernetes and get started here. And then this is all running on top of Amazon. And I mentioned we have public cloud drivers for Amazon. So if we switch over to OpenStack, you'll notice that we've discovered these 9 instances here and automatically brought them in because they got provisioned inside of our EC2 console. There's the instances. And we automatically discovered those with OpenStack. Right, so that's kind of how our OpenStack and Kubernetes stuff works together, whether you're running on KVM, VMware, or the public clouds. So I kind of want to show the deployment of a Kubernetes cluster. It's pretty easy. You'll add a cluster here, choose the cloud that you want. We're going to be deploying in AWS. We'll call this demo. And I want to deploy in US West 2. In US West 2, they have 3 availability zones. We're going to pick all 3 of those guys. And we'll create a scaled out Kubernetes cluster across all 3 availability zones. I like deploying Kubernetes on Ubuntu. That's my preference, so we'll choose that. And then what instance sizes do you want, right? So standard M4 larges are pretty popular, so let's go ahead and do that. Almost every region has those. 3 master nodes. If you're familiar with Kubernetes, you can run single masters or multi-master. Obviously, if you're running production and you want stuff to be highly available, you're going to want 3 masters for that etcd. So we'll go ahead and keep that. Let's also create 3 worker nodes as well. And we're not going to enable spot instances today. We're just going to kind of burn through this. And I'm going to create a Route 53 record on the fly. I'll create a brand new VPC for this environment. So we'll create this cluster in its own VPC, and it'll have DNS records ready to go. And then all of the systems that I SSH into, or all the systems that we create, I'll use my SSH key so I can log into them. And then we have a Helm application catalog that I'll also enable so that you have Helm natively in the cluster. Right? So pretty easy wizard. We create that cluster. This is then going to automatically error out. And, oh, my instance limit's exceeded. That's great. I have 0 or more running instances. You requested at least 1. Well, that would have worked if Amazon didn't limit me to almost no instances, which is lovely. Thanks, Amazon. Cool. So that's how you deploy a cluster. Luckily, I already have one running, because that would have really sucked if I didn't have one running, right? So I have a cluster running here. So I downloaded the kube config earlier. I should be able to control R export. So I'm going to export my kube config for this cluster. It is called OpenStack Summit.yaml. So kubectl git nodes. And you can see this is the cluster I'm running, Kubernetes 1.9. All right. So we are now at the point where we can actually deploy Fission, right? Our serverless framework. We have a Kubernetes cluster that's up and running. You can use Minikube. You can use anything that you want, but you need Kubernetes as the base for this serverless framework. So very easy install. Go over to fission.io. And to do the install here, we have the install guide. It's a simple Helm chart. So if you're familiar with Helm, really all you have to do is run Helm install right here. Just copy this line. So Helm install, we're going to put it inside of the Fission namespace, and we're going to be creating services of type node ports. Let's see, is that correct? Is that the one I want? No, it's not the one I want. We're not running a Minikube, we're actually running on the cloud. So we're going to be creating service type load balancers, so that it'll load balance across the cluster, and we will deploy this guy. So simple one-line install to get our serverless framework up and running. So that's really all there is to it. And I have that in another cluster already up and running, so we're not waiting for loading screens and whatnot, because that's not fun. Come on. I just want to have it show being created. Going once. All right. So now we have Fission, right? So we have a nice command line utility. Should be able to do a Fission function list and list any functions that you have. I have one that we'll be doing a demo a little bit later. And then Fission has a couple constructs. We have the concept of environments, right? So that's your runtime, right? So Fission environment list. You can see I have a Python environment. So the examples I'm going to be running today are Python. We support NodeJS, C#. You can actually run binaries, simple bash scripts, or any executables that can run on Linux. Ruby, PHP, you name it. We have an environment that you can build your scripts in, right? So you have your environments, and then you build your functions. So a simple example of a function looks like this, which is a simple hello world. It's 2 lines. You define main, return hello world. That's all there is to it. That's your function. And then we have the concept of routes. How are you going to hit that function? How are you going to execute it? Right? So the route here is going to be /hello, and you need to do a method of get to execute this guy. Right? So very simple. And if you're savvy on heat, I've already kind of jumped over to the heat side of things. You can see this is a heat template, and this is all you have to do to define a Fission function. You have all the deals that you need here. You give it a name, hello world. You have a Python environment that you want to use, the /hello route. I want to execute this with a get method, and paste your code right in here. Very simple. So let's do this. So let's go over to our environment here. And I promised as part of the description that we wouldn't just be doing this with heat. We're going to be building a application catalog to do anything as a service, right? A really catchy catchphrase. We've got some of you in the room. I like it. So we'll create a new application here. This is simple Murano. This works on Horizon as well, but this is just the Murano application catalog. So we're going to upload the components, and just so you know I'm not doing any trickery here, I will be copying from this Sublime text deal. We'll call this hello world. And then I have a really cute little hello world picture here to upload. This is kind of a web type service, so we'll choose web, and we'll upload this guy. So we just uploaded this to the Murano app catalog. So let's go ahead and deploy it, right? We'll do a one-click deploy. We'll call this hello-world. And we're going to deploy this function. So this is actually going to call out to Fission. As part of the heat configuration, you have to specify your Kubernetes config. Heat then uses Kubernetes port forwarding to connect to the Fission services. So it's secure and goes over HTTPS and does all of that. And then we'll upload your Fission functions and packages all that way. So that's how this has worked. So as part of the setting up the driver inside of Heat, that's all you have to do is give it that kube config. So we're deploying this guy. Hey, it's ready. Great. So we have an orchestration stack here. Apparently I had a test before I was here that failed to delete. Let's delete the test. All right. So we have our hello world. You can see that our hello world deployed successfully, and it can be accessed at /hello. Okay. So let's jump back into Fission and just kind of see what that looks like. So Fission function list. Hey, I have a new function here that wasn't there before. It's called hello world. It uses the Python environment. And then I should also have a Fission route list of /hello, right? And it's using the method get. So, and you guys can play along at home if you want. But if you want, go to fission.pf9.io/hello. Oh, don't make a liar out of me. Fission.pf9.io/hello. Come on, man. let me just test the function real quick. Hello world, what's wrong with you? Oh, stack trace. So that's what's wrong with the function. I threw a nice stack trace, which is great. Let's, I can fix this. So let me do a Fission environment delete -- name Python. Fission environment create -- name Python. So what would happen here is the environments that I built, the Python environments for this demo and the next demo aren't compatible, so I'm going to have to do this again. Fission environment create Python -- image is Fission : or no, what was it? It's this guy. That environment, that should work. Let's test that guy one more time. Hello world, great. So now when I go to the public URL of fission.pf9.io, I get a nice hello world. So that's kind of cool, right? I used heat to upload a Fission function into my environment, and I can hit it from anywhere. But we can also hit it from heat, right? So we can actually call these functions and get their result back from heat. So let's do that. Again, we'll come in here and we will upload, create a new application, and we'll upload this guy. We'll call this call hello, and we will add that very simple function call here, right? So it's much less code on the function call, but more outputs because we're getting data back. So a simple OS heat Fission function call. I'm going to call fission.pf9.io/hello, and I want to do it with a get method, and it's going to return back the route that I hit, the return code for the function, and the data for the function, right? So then you could use this data in the rest of your heat stack, right? So maybe you're calling out to your IPAM service and saying, hey, what's the next available IP? Great, let me use that or something. Or you could be creating 80 users or anything that's you fancy. All right, so let's try this thing out. So we'll put that guy in there. Again, cute little logos. Let's do the hello call.jpg, and let's upload that guy. Again, we're doing kind of webby stuff, so we'll choose category web. And there, I have a little telephone here. We're going to call hello. So one-click deploy, call hello, and deploy that guy. Again, this should deploy pretty quickly, right? Because it's, I mean, all it's really doing is a simple get REST API call, returning the results to heat to use. Cool, it's ready. So we can go in here to orchestration, and we see that we have the call hello here, and it actually returned hello world, right? So we got back the data from this function. It's pretty cool. But what's kind of a real world example to this? Right? And one of the things that we haven't built yet is a designate integration. If you're familiar with designate, it's the DNS service for OpenStack. We haven't built a designate integration for Route 53 inside of OpenStack yet. We're going to, because we have the public cloud, Omni drivers, and all of that, and that's just a logical progression that we'll do that. But in the interim, if I create a server inside of AWS, I want it to have a DNS record, right? So let me show you what that looks like. I have a route53.py here, right? Fairly simple script. It's not too long. And I'm kind of leveraging and pushing the edges of almost everything Fission can do here, right? So what are some of the issues with running code like this is that you need credentials that you need to secure somehow. And you don't want to give those credentials to your end users because then they have the keys to the kingdom, right? Like your access keys and secrets for Amazon. And you might have some configuration maps as well inside of your environment that would configure this function. So I'm calling those things out, right? So I'm actually using Kubernetes secrets. So I'm mounting a Kubernetes secret and getting my Route 53 access key and Route 53 secret here and storing those into a variable. I also have, Fission has this cool concept in its routes. If I do a Fission route list, is in this route, I have this goofy zone name in brackets here. Maybe, I don't know how legible that is. We'll kind of do that. So you can see I'm calling /route53, brackets zone name, and then record. And I'm doing a post call to this guy. So what this is going to do is when I hit this URL endpoint, it's going to basically deliver whatever string blob I put here back into my function at this variable name, right? So we have the fission param zone name. So this is now a Route 53 function with my config map. My config map, I should be able to do a fission, or sorry, kubectl -n fission get config, get conf, get config, config map. There it is, config map, no hyphen. So I have my Route 53 config map. So if I you get this and then do an -o YAML, you can see it's a very simple config map where I have some data of a few different Route 53 domains, right? So I have pf9.io, I have platform9.beer, because why not? And platform9.horse, because it's funny. So those are the friendly names, but in Amazon, they use these zone IDs, right? So I'm just mapping those so you can use a friendly call, and I'm pulling those guys out, right? The secrets are very similar. I'm not going to show you those because then you have access to my AWS account. So that's how I'm doing that, right? So then I'm simply just getting this data, and I'm passing in two variables here. I'm passing in the host name and the IP address that I want to create, along with the zone inside of the URL, and I'm going to have an A record. Okay, cool. But that's not cool by itself. What makes that cool is I'm going to be doing this as part of an entire heat stack of deploying a server, installing Apache, getting that up and running, and then creating the DNS record in Route 53 for that server. Creating floating IP addresses, all of that, right? And so you can see all of this is standard heat stuff, right? Creating a server, floating IP address, associating it, user data, creating an OpenStack port, and a security group. Very simple stuff. But this is going into Amazon. So again, use the heat template language that's universal across all of the public clouds, universal across KVM and VMware, single language. And we could write this thing. And then at the very end here, I'm going to do a fission function call to the domain that I specify as part of the input parameters. And use the host name that I specify as part of the input parameters and the floating IP address that this thing automatically creates. And I'm going to create that DNS entry, right? Pretty cool stuff. Let's try it. But I also mentioned that my environments aren't compatible, so let me do a quick rebuild of that environment. Failed to apply spec environment. Oh yeah, it already exists. So I need to do a fission env delete delete -- name Python. All right, cool. So in this, as part of this, I'm sure if anybody has touched Python or Node.js or Go, you have dependencies, right, to packages that you need to use. So to do Route 53, we need Bodo installed. Right, so very simply inside of the directory I'm in, I have a requirements.txt with Bodo, right? I then have a build.sh script, which is the only line that's not commented out as a pip install for that requirements. So on the fly, when that environment's being created, it's creating a fission function, or it's creating a Kubernetes pod, which is a container. That container gets a set of containers. The containers get created, and then it runs after the creation of the container. It just adds your modules in there, and it does a warm start of that pool of containers. So that's what I just did. Is I built that environment and then did the warm start for me. Cool. So now let's grab this guy and run through it again. So applications, create new application. I'm going to upload my component files here. We're going to call this Apache server with DNS. Paste that guy in there and browse for a nice Apache logo. Upload, web, public, go. Cool. So now we have an application catalog where your end user that needs to do some web development, they really don't know how to build an Apache server and do all of that, or DNS records, or you don't want them in that system, can just do a simple one-click deployment of this environment. And then there's some input parameters that they need for this heat template, right? So first of all, what domain do you want your DNS record to be in? pf9.io. We want to attach it to the external network, right? So that's the Amazon global external network here. We'll use a CentOS image for this. The host name is going to be OpenStack Summit. How about rocks? I'm setting a root password for this system. That's more for debugging. And attach it to a private network, give it an M4 large flavor and an SSH key, right? So do it. So let's deploy this guy, right? So we're deploying this, and we'll see that fairly shortly, one of the first thing that runs is that floating IP gets created. And as soon as we have the floating IP, the Fission function call can get executed to create that DNS record. So we can see the create is in progress for do it, and it's already ran. So the Fission function call ran. It got a return code of 200, which is good. And this is the exact REST data that we sent to it. Host name is OS Summit. I don't know how visible this is. OS Summit rocks. IP address is the public IP. You can see this is an Amazon IP address, 18.219.67.236. And then the function data returned this code here. So my function could have been a little better and kind of pulled for this thing to finish, but I got a result of pending, and that's good enough for me because I'm an architect and not a developer. Cool. So that's building, and you could see that over here we're actually spinning up an OpenStack instance, right? So here's the OpenStack instance that's coming up. Let me get rid of this so we have a little bit more room. We have do it server 1. It's getting spun up. So first, let's jump over to the Route 53 console and make sure our DNS record got created, right? So we should have a, what do I call it, OS-Summit? OS-Summit rocks, right? So right there in Amazon, we have a Route 53 entry for OS Summit rocks. It correlates to that 18 address that ends in 236, which is, I assume that's the right one. Ending in 236. Yeah, that's the floating IP address. So the Fission function kicked off. We got our DNS record. That's cool. And then if we jump into the EC2 console, we can now see we have a server, right, being built inside of AWS, do it server 1, and it's initializing right now. So as part of our, it's running, it's up, and I could probably, I can't SSH to it because the floating IP isn't assigned yet. But as part of our Omni integration, we actually wait and do the, make sure that we get back the 2 successful health checks. The system not only actually got spun up and said, hey, it's running, but it's actually healthy, right? So that then tells Nova, hey, the server build is complete. We actually have a healthy server, and it's not in some goofy state, right? So this takes a little bit of time. I was shocked at how long Amazon takes to do these health checks. So it takes a little bit of time. So while this is going on, I'm going to jump back into a couple more slides and just kind of talk about Fission a little bit more. Why Fission, right? Why do we decide to do this, right? So what we've been learning by going through Kubernetes and working with a lot of developers in the space, you know, like I mentioned, since 2015, we've been working with Kubernetes, pretty early days. And on average, to get a standard microservice up and running and have it working end-to-end where you can use it is about 6 weeks for a developer, right? It's a lot of time to do that. And even though that's way better than a monolithic app or running it in a different way, it's still a little too long, right? And then there's a lot of real world roadblocks, right? So Windows folks need .NET support, right? Doesn't really work very well in a lot of environments. It's difficult. So we actually built, we have C# that works on top of Linux, so .NET Core. So we kind of help folks do that, and that works well. And then debugging and operationalizing and doing rolling upgrades and all of that for your microservice requires the developers to really dig in and learn Kubernetes, and if they're having to learn a new framework and a new way to do things, and they don't want to do any of that. Developers want to write cool code and see it work, and that's about all they want to do, right? So that's what we're looking at with this, is they get to write their code, they get to do a Fission function upload or create, and they can test their code immediately, and they don't have to worry about anything else. And yeah, the second line is all the complexities, right? You have services, you have pods, you have deployment, stateful sets, ingress controllers, egress controllers, all these things that you have to focus on and worry about with Kubernetes that Fission just kind of lets disappear, right? You don't have to worry about those things. It handles it for you. And at the end of the day, the code that you wrote is now running in production. It's scaled out across your cluster, and it works great. So what does Fission enable? I kind of talked about this, right? It's basically web-based services, REST APIs, you can hit it, but we also have other hooks inside of Fission as well. So inside of Fission, you can use cron functionality. So this is, I was a sysadmin back in the day, so I immediately, when I had a bunch of scheduled tasks and reoccurring cron jobs and all of that, and then the server that those are all running on goes down, you're kind of SOL, right? Or somebody powers it off or reboots it or does something. And what this does is with Fission and its cron functionality is it distributes these, it runs your cron job on a timer, it then deletes and destroys the pod and it's done. And then you have the entire power of that Kubernetes cluster that's kind of running your cron jobs. You can also tie into message buses. We support getting a hook from a message bus. I believe Kafka's supported. There's another one that's kind of cool and sexy. I forget the name of it right now. That we support. So you can any trigger off that message bus, you can basically do something, run a Fission function. I know we've been working with Minio, so if you upload something into a Minio bucket, you can kick off a Fission function, right? So these are some of the different hooks that we have. So not just REST-based stuff, but you can do this on events. And then any Kubernetes event that happens, you could say, hey, this somebody created a new namespace. I want to trigger a Fission function to do something when that namespace is created, right? So yeah, Fission's pretty cool in that way. And why does it run on Kubernetes, right? Because of all of the coolness that Kubernetes also abstracts for you, right? So the config maps and secrets I explained a little bit better, or a little bit earlier. The native GPU support in Kubernetes, you can now build a function, get a GPU, and have that function work with that GPU, and then it's done, right? It can go away. So all of the native cool things that Kubernetes is doing that developers want to leverage are natively available inside of Fission to take advantage of, right? Persistent volumes and all of that. Cool, so hopefully I've talked long enough. Hey, it's running. Great, so it's running, and hopefully it got its floating IP. It did. So it's running, it got its floating IP, so it's at 18.219.67.236. Cool, so for this to work, I should hit its actual DNS name, which I forgot what that was. It is OpenStack Summit Rocks. All right, so if my Cloud.net skills are good, I should be able to hit HTTP. And this guy. Hey, and I have Apache up and running. So full DNS name, Apache web server, all of that from a single heat template, right? So yeah, so that's kind of what I wanted to show you guys. So everything that we're doing is open source. So if you go to github.com/Fission, You're going to see all the stuff that we have here. If you like what you're seeing here, we appreciate GitHub stars. So we have almost 3,300 GitHub stars. If you want to go ahead and add to that, we appreciate it. And then all of the code and examples and this Heat plugin for Heat that will run on anybody's OpenStack, right? It's just a simple plugin for Heat. Will be in this repo in the coming weeks. We're just going to make sure we have tests built for it and all of that, so you guys can contribute and add to it, make it better, and we can treat it like a true open source thing. So look out for that here. GitHub.com/Fission for all of that. And this brings me to 4.5 minutes between me, you, and lunch. Questions? Come on, there's got to be questions. Was it that bad or that good? It was good. You guys liked it. That's cool. Yeah, show of hands, who's used oh, you have a question? There's a mic right there. That way the video can get it and everybody can hear. There's also a mic over there if somebody wants to line up.
That's good presentation. And my question is, compared to other Kubernetes open source serverless project, what's the advantage and the benefit of the Fission project?
Yeah, it's a good question. So with AWS, you have Lambda, and all of these cloud environments are building their proprietary, for the most part, serverless framework. So the benefit of Fission is that, A, it runs anywhere. So you can run it in your private data center. You can run it across all the public clouds. And it's completely open source, so you can contribute to it and do that. And then it has the what I mentioned before is the native pieces of Kubernetes that you can leverage inside of those serverless functions that you don't really get with Lambda and the like, right? So you're really kind of building on top of Kubernetes and being able to leverage that. Did that answer your question?
So there are a lot of other open source projects also for the serverless. It's also built on top of the Kubernetes.
Sure. Yeah, Kubeless, XaaS is another one.
Right.
Yeah, and there's a good write-up, and I honestly don't know all of the nuances between all the different projects, but there was a good write-up of somebody doing a comparison. From what I've heard, Kubeless is basically dying. It came up, it was kind of cool, and then it's kind of dying off. XaaS is getting a lot of traction, and we're chatting with those guys and collaborating, and maybe I don't know what happens in the future, but yeah, so it's a very new space, right? So when same with container orchestration came out, right? There was Mesosphere and there was Docker Swarm and there was Kubernetes, and Kubernetes ended up winning that kind of format war. We're all kind of looking for our edge and all of that right now. And the barrier to entry to get up and running and how easy Fission is to use, I think is kind of our edge right now. Yeah.
Yeah, I think it's related. How is a chain link and Fission is going to be related, or are you going to guys working together, or?
I'm sorry, I didn't understand the question.
Chain link.
I don't know what that is.
XaaS under, I think.
Is that another XaaS service? Yeah, so I don't know what they are.
Under OpenStack, I think there is a new project getting created.
Oh, okay. So there was a talk this morning that I couldn't attend because I was working on this that was about the new OpenStack serverless deal. Is that what that is, called Chainlink? Okay, I wanted to watch that talk after they publish it because I was very interested in it. One of the things that we have that's powerful as well is Fission Workflows, right? So that's something else that kind of sets us apart from a lot of the other functions as a service, is that of course, you could create a Fission function and then, or a serverless function and have it build the REST API call to have it call another Fission function and return data, and you could chain them together yourself just doing RESTful things, right? But we figured that was a lot of work to do. And so we built Fission Workflows that allows you to kind of define kind of like a heat template, so to speak, but for your Fission function. So I want to enter here and run this function, and then I want to run these 10 functions in parallel, and once all of those are finished, they will feed their data to this next function, and this one will loop 10 times. And so there's all these different constructs in Fission functions that'll allow you to kind of build a full workflow of these. So you can kind of reuse and chain these things together. Any other questions? The timer just hit 0. Oh, go ahead. Last question.
Hi, I have a question about the trigger you mentioned last two slides. You said you can set kind of event related to the OpenStack, but do we have to prepare something consumer for RabbitMQ listening to the OpenStack notification and execute that Fusion, or you have already something agent to listening the event and execute this Fusion function?
So that's one that I have been asking for internally. We don't have it built yet. So we have the, I believe we have the RabbitMQ generic. If something happens in RabbitMQ, we can trigger a generic Fission function. But we haven't tightly integrated it with the notify queue of OpenStack yet and made that super simple and easy. And I've been asking for that, so I'm glad you're asking for it, and we got it on video. So now maybe our engineers will enable that. That's definitely something that I want to see happen.
So, okay, I'm looking forward to it. Actually, we are thinking to implement something similar things. So I hope
it's open source.
Yeah.
Fission.io. You could definitely contribute. We would love contributors. We'll send you a cool sweatshirt and all of that if you do some contributions. So.
But do you have any specific working group for integrating this Fusion into the OpenStack?
I don't think we have an OpenStack specific working group. We're kind of working. So we're working with the. Is it Open Compute Foundation or one of the open consortiums that we're trying to get Fission accepted into, and we do our collaboration today off of GitHub, and we have a public Slack channel, and you know, we have a handful of contributors to the project. I don't know how many today, but it's 64 different contributors or so are working together around the world to kind of get this thing up and running.
Thanks.
Yeah, thank you. Anything else last minute? All right, I'll hang out if you guys want to like do a one-on-one chat with me, but thank you for your time.